Good evening to all. Today we are going to see one important topic from theory of motion 2, that is the vibration. That is, actually we are going to say it as a separate part of theory of machine, and we have to deal it with separately. We can have one separate subject also for this vibration. As it has been included in our syllabus for some of the chapters, that's why we are going to see that some chapters from the vibration. Out of that, the chapter which we are going to deal with today is the fundamentals of vibration, and we are going to see some types of vibration, as well as we are going to see how to calculate the natural frequency, or how to derive the mathematical formulae for calculating natural frequency of single degree freedom system without damping. So first of all, if we are going to see, that is fundamentals of vibration. Now when we are going to start this unit, at that time first of all we should know what you mean by vibration, and then afterwards we can go for the causes of vibration, then afterwards we will see the types of vibration, then afterwards we will see the analogy of calculating vibration, and then afterwards we are going to derive a formula by means of which we are going to calculate the natural frequency of single degree freedom system without damping. So if we are going to see this term vibration, this term vibration means the motion of a particle which repeats itself. That is, when we are going to see the motion which is going to repeat itself, that motion we are going to say as a motion is coming under the vibration. But when we are going to see this repetitive motion for the mechanical parts, then we are going to say that part is going to vibrate. Now, depending upon the types, that there are different types by means of which we can categorize the vibration, but vibration word is nothing but the combination of some terms which we are going to use to understand the vibration. That is, if you are going to see this vibration, the motion which may get repeat, and very simple motion which we are going to get, which is very simple to understand and simple to explain, is the sinusoidal motion. And this sinusoidal motion, because the complicated vibrations we are going to convert into simple one, and first of all we are going to see what the simple, how we can have the mathematical model for this simple motion, and then afterwards we can go for the complicated. So when we are going to see this vibration, in this case, if suppose this particle is going to repeat its motion, then we are going to say that the particle is in vibrating condition, and we are going to see this getting this sinusoidal wave. This can be analogous to the particle which is moving on the circle. Suppose we are going to have the center of circle as a O, we are going to get some point X at this position, and if we are going to have this distance which has been travelled by, vertical distance which has been travelled by this particle is the X. If suppose we are going to have radius capital X, the small deviation which has been taken place from the horizontal line is theta, and if this particle is moving with the angular velocity omega, uniform angular velocity omega, and if suppose it requires time t to reach at this position. So what we have done is that this particle A is moving along the circle. We have captured one photograph when that particle is at position of A, and at that time this X, and we want to find out what the small x is, that is how much vertical distance this particle has moved from the horizontal line. And if we are going to project this on the vertical axis, and if we are going to get this repetitive motion, because when we are going to trace it, it will have the repetitive motion. Likewise, we are going to trace same repetitive motion on time axis, and it is called as amplitude axis. So we are going to get that motion, where this maximum amplitude which we are going to get is the capital X. Okay. Now one can write equation by observing this triangle OAA dash, that where we can write as x is equal to capital X sin theta. This capital X is the radius of circle where we want to find out one side of the triangle, and where we are going to write this x. Now this theta can be written as a angular velocity multiplied by time. So when we are going to get this angular velocity multiplied by time, then we can say that theta is replaced by omega multiplied by t. So I will write this equation as x is equal to capital X sin omega t. This we are going to get as a displacement is equal to x. Now this displacement we are going to get for the particle A. We can calculate velocity also by taking its derivative. That we can say this as equation number 1. If you are going to take the derivative of this equation 1, equation 1 with respect to t, because t is the variable here in this equation. Omega already I have told that angular velocity, and which is constant. X is the radius of that circle, which is not going to change. That's why x is constant, omega is constant, only variable is t. That's why we are going to take its derivative with respect to time t. When we are going to take its derivative, at that time we can derive it that d by dt of x is equal to, we'll write it as a x dot. Single dot indicates that single time derivative. Okay. So when we are going to write this as a x dot, it will be derivative with respect to time t of this x sin omega t. Now when we are going to take derivative, here x is constant, we have to write the derivative of sin is equal to x cos of omega t multiply with omega, because omega is again constant. So we are going to get x omega cos of omega t. That is we are going to get as a x dot, and this is nothing but velocity of that particle, because we have calculated as a x, that is small x here as a displacement. Here we have calculated x dot as a velocity. Now we need to calculate acceleration also, because these terms which we are going to calculate for the repetitive, if you are going to say the motion have displacement, it has a velocity and it has acceleration. Even higher accelerations we can also calculate, but in some cases that higher accelerations are required to be calculated, and we can limit our study up to the acceleration only, that is the double derivative of displacement. Now when we are going to take double derivative of this displacement, one can say that it is nothing but the single derivative of velocity. So when we are going to calculate acceleration of the same particle, we have to do derivative of this x dot, that is ddt of x dot. Now when we are going to take this second derivative, we will denote it as x double dot. Now this x dot or x double dot I am going to replace for the derivative. For again simplicity, only I can write the dots instead of writing this d divided by dt. That's why I am going to mention only dots. So when we are going to take derivative with respect to time of this equation, that is x omega cos of omega t, then we can write it as a x double dot is equal to minus omega x. Derivative of cos omega is sin omega t. Again ddt of omega t will be there, that is we can write as omega. Omega is the constant. So it will become minus omega square x sin of omega t. This will be the double derivative of this simple harmonic motion. This is single derivative, that is the velocity of this simple harmonic motion. It is denoted acceleration. Now these three terms are important in vibration, that is displacement, velocity as well as acceleration. Once we are going to get this displacement, velocity or acceleration, then we are able to understand the vibration. We are able to have the mathematical model of that physical system which we are going to study for the vibration. Now next part which we are going to see is this is what the fundamental things which we should know about the simple harmonic motion or any repetitive motion. Now this can be analog with the vibrating system. Let me tell you one thing, that is vibrating system is nothing but here I am going to model a simple system which includes spring, mass only, and it has a maximum deflection from its mean position. It is going to deflect by amount x meter or centimeter or millimeter, whatever may be the unit in which you are going to measure the displacement. It has a maximum deflection in upper side by amount x. It has a maximum displacement at the lower side by amount capital X, which we are analog to the circle, which we are analog to the harmonic motion also, which has represented by means of sinusoidal curve. Again, this sinusoidal curve is known as a sinusoidal curve because it is denoted by a sine component of the trigonometry. That's why it is called as sinusoidal curve. Now next part which we are going to see, that is the various terms which we are going to use. Related to this sinusoidal motion, that is when we are going to write this sinusoidal motion or repetitive motion, this distance which has travelled on time axis we are going to call as a time period. Now this time period, which is denoted by capital T, is given by 2 pi upon f n, or simply we can write as a frequency. Here I have written this frequency in terms of f. It can be replaced in terms of omega also, because omega is nothing but the velocity by means of it is going to repeat, that motion is going to repeat. Then one can write the frequency will denote it by f, which is nothing but the reciprocal of time period, that is number of cycles completed in 1 second, and this time period is nothing but the time required to complete 1 cycle, 1 complete cycle, that you are going to write as a time period and frequency. Now study of this time period, frequency and displacement, velocity and acceleration of a repetitive motion, that you are going to say as you are going to study the vibration. So when we are going to see this vibration, at that time we have to study all these parameters, that is displacement, velocity, acceleration, as well as time period and frequency. It includes everything. Now this is for the simple vibration. Now we are going to see what are the different types of vibrations. Once we understand what the parameters which we have to study under the vibration, then we can see types of vibrations. Now these types can be, we can say that there are different types by means of which we can get the vibrations, but fundamentally or basically we have to divide this vibration in its broad categories, and later on it is going to become coarse, because it is again, vibration is a very vast topic, and in which we can detail out our study and we can go for that particular type. But when we are going to see from the bird's eye, at that time we are going to have some broad classifications of vibration. Out of that, first is called as longitudinal vibration. Second is transverse. And third is called as torsional. Now when we are going to see the longitudinal vibration, let me draw here simple diagram of any vibrating system. Suppose this is a mass which has connected by means of this wire or any rod. At that time this can be replaced for the mathematical modeling, that all stiffness we can put as a spring, all mass, that is including mass of this shaft as well as this mass which has been hanged by means of one support rigid body. It can be replaced by means of this equivalent system, that is we are going to say all stiffness is converted into spring and all mass has been concentrated at certain mass level M. So when it is vibrating,